Assalamualaikum and greetings everyone. Welcome to my final year project proposal presentation. My name is Nur Syafiqsh Binti Mihat from 4SSCMH. The title of my FYP is SOLUTE Dispersion of a two fluid models for blood flow through a stenosed artery. I am supervised by my lecturer Dr. Nur Binti Mihat. So, let's begin with the introduction of the studies. CVDs are the primary cause of death worldwide and have attracted a great deal of attention these past few years. The Malaysian Ministry of Health report showed CVD remained the leading cause of death from the 1980s until today. And the aim of this study is to formulate two fluid model of Jeffrey and Newtonian fluid and mathematically investigate the dispersion of solute in blood vessel with the effect of relaxation time, stenosis height, and pressure gradient in the stenosed arteries. Next part will be the reason of my study. It is to understand the flow dynamic of two fluid models in developing predictive model for assessing disease progression and optimizing treatment plans, because this dual fluid method gives a more accurate picture of blood behavior. The unique property of the Jeffrey fluid involves a parameter known as relaxation time. It plays a role in the fluid's ability to recover from deformation. It is also to measure of how quick the fluid's microstructure adjusts to change in stress or strain. Analyzing relaxation time in these fluids contribute to insight into circulatory issues, drug delivery or joint disorder, enhance our understanding of psychological process and potential medical intervention. This is the objective of the studies. The first one is to formulate the mathematical model of the two fluid, which is Jeffrey and Newtonian fluids, in a stenosed artery. Then to solve momentum and constitutive equation to obtain the velocity of Jeffrey and Newtonian fluid in a stenosed artery. Next is to solve the unsteady convection diffusion equation using GDM or generalized dispersion model to obtain the dispersion function, dispersion coefficient, mean concentration, and longitudinal diffusion coefficient in cosine stenosed artery. And last one is to analyze the solute dispersion in two fluid model, which is Jeffrey and Newtonian fluids model, with the effect of relaxation time, stenosis height, and pressure gradient. Now I will show the blood geometry of two fluids model. If you look at the geometry, you will notice the presence of yellow colored substance attached on the arterial wall, and that indicates the presence of stenosis. And we know that the blood flows through the arteries with velocities, and we treated blood as a two-fluid system with the suspension of red blood cells in the core region as non-Newtonian of Jeffrey fluid, and the plasma in the cell-free region near the wall as Newtonian fluid. I will explain the method by using a generalized dispersion model or GDM. There are three equations that need to be solved. Okay, so the first one is constitutive equation of two fluids model, which is J indicates the Jeffrey and N indicates the Newtonian fluid with boundary conditions, and RZ is a stenosed artery. So next we have momentum equation and convective diffusion equation, and the last one is the generalized dispersion model. As we come to the end of this presentation, I hope that this proposal will be useful for researchers to consider the solute dispersion of a two-fluid model for blood flow through a stenosed artery with the effect of relaxation time, stenosis height, and pressure gradient, as this study has not been done yet by any other researcher, and also to provide an extensive overview of the matter of cardiovascular disease. I believe that the predicted finding will be beneficial in addressing the matter of cardiovascular system dispersion. And I think that's all from me with regards. Thank you.